Thank you, Michelle. Looks like we have a good number of people joining, some more people trickling in, but let's go ahead and introduce the presenters. So Michelle, could you go to slide 2, please? So my name is Misha Goffstein. I'm a Chief Executive Officer of Macrofab. Joining me today for this webinar is Ted Pawella, and Ted is the Chief Ecosystem Officer for Altium, and Greg Paulson, who's Director of Application Engineering for Xometry. So Ted and Greg, thank you for joining us. We're very much looking forward to the discussion. We will have a chance to take questions at the end, and in fact, feel free to bring up those topics in the chat now. Michelle is going to be our master of ceremonies and will let us know if there are any questions. But let's go through the agenda and we'll take on one of the first topics. One of the first things that we wanted to cover in this discussion is the current state of digital manufacturing, products built on digital platforms. This space has been evolving and has come a long way. So one of the objectives we have is to help you understand what kind of products are being built out there and how people are building them. We're going to discuss some of the digital design manufacturing patterns, why digital manufacturing even exists and what problems are being solved. Ted is going to cover topics around design to manufacturing tool chain. Design software is now becoming part of the digital manufacturing domain, and we're starting to see end-to-end collaboration with companies that goes from all the way from design stage to production. Greg is going to discuss mechanical parts production. Xometry supports a lot of processes, can build a great number of mechanical parts which are used in electronics manufacturing. In fact, both Macrofab and a lot of our customers routinely source their materials from Xometry, so we are very familiar with the business and how it's used in both early stages of design and later stages of production. And then I will follow through with a discussion about electronics manufacturing, putting it all together and actually getting it to production scale. And we'll close out with a discussion around accelerating around supply chain disruption. That's been a lot of what our customers turn to us over the last couple of years. It's not just the pandemic anymore. There are just a lot of vectors that are disrupting the supply chain now, and agility is all of a sudden not just a fanciful word. It actually means something. And we'll close out by discussing what the future of digital manufacturing looks like. So full breadth of topics. We have a lot of content here for you guys. Again, thanks for joining us. So Michelle, can you go to the next slide? This is the overall landscape of what a reimagined factory looks like, and I purposely made it very small because all of those icons you see on your screen, it looks like a Milky Way, galaxy of startups and galaxy of solutions that are helping people modernize and reinvent the factory. It's great to see. In fact, vast majority of the innovation in manufacturing happened before the cloud, and I think a lot of the cloud concepts are now starting to invade the factory floor. There's been billions of dollars invested into reinventing the factory, but it's a very broad range of solutions. It's everything from MRP software, manufacturing resource planning solutions that are used by large OEMs that have their own factories, all the way down to design tools that really help you automate inspection of product as it comes off the production line. So huge number of companies out there. In fact, I think one of the things that's somewhat frustrating now is just difficulty in understanding, what all these companies do and what should you be using. We really don't see we haven't seen a wave of consolidation yet. We're seeing more and more of these companies come to market. The segment we're really going to focus on, and we're going to go fairly narrow. We're going to talk only about electronics products, and a specific domain we're going to discuss is digital manufacturing platforms. These platforms are growing up fast. They now have thousands of customers, and the fascinating thing is that they produce everything from mechanical parts to PCB assemblies to fully assembled electronic products, and even heavy machinery. Believe it or not, you can go online now and order a crane or a tractor that's going to get assembled for you in India, and it will get shipped to the United States. And you can do that without having to travel to India at this point. So a really fascinating constellation of services out there. We're going to focus on electronics for this discussion. But I think the other interesting trend between these companies is that we have moved on from the stage where companies are buying digital manufacturing equipment, putting it in their shop, and putting a digital interface on it. In fact, I think earlier companies like Protolabs, Plethora, and others, that's really where they started. They really own a single factory, and that factory is connected. But the latest wave of companies that's really scaling up much faster, and I would say both Xometry and Macrofab fall in that category, are really operate as networks, right? And these networks aggregate a lot of factory capacity. So one of the things they give you is not just the digital experience of building your product, but also a lot of factory capacity, both at small scale all the way to large scale, so you can scale up and really stay on the same platform, switch the production process, move to a different scale of a factory, but without really having to leave a single digital environment. And that's pretty exciting because that means that we're starting to consolidate the use cases, if not the companies themselves, right? So if you go to the next slide, the question naturally arises, what problem are we even solving, right? And in fact, traditional manufacturing was tremendous for a number of years, especially for contract manufacturing. Really grew up in the 90s, right? Right as the internet was starting to scale up. Contract manufacturing was all the rage. Believe it or not, only 1/3 of all electronics manufacturing is still done through outside companies. There's a lot of businesses still that own a lot of their own manufacturing facilities. But for the most part, the cloud model and ability to do agile development and iterative development really passed up a lot of the traditional manufacturing environments in this space. So what we see is a lot of waterfall development, slow design iteration. It takes months or years to go launch a product. Electronics design to product cycles could be 2 years. In automotive world, it could be 4 years. The shortest we've seen is kind of 1 year, but it takes a lot of agility in order to get that done. For years, supply chain has been optimizing purely for cost. So we've seen, we're seeing crazy situations now where it is so perfectly competitive, anti-competitive now, to where there's 2 factories producing a component, and if one of them has a fire, there's a global shortage. This is affecting every aspect of supply chain. It's not just COVID. There's a lot of reasons why supply chain is brittle now. All of it has a compounding effect on just complexity and manufacturing. But the real impact is, at the end of the day, it's a lot of engineers sitting in a lot of phone calls, emails, and meetings, and even that isn't really working these days, right? If you work for a large company, it used to be very common for you to get on a plane, fly to China, go troubleshoot the production process on the factory floor. That's not happening anymore either. So a lot of traditional manufacturing has been long in the tooth, and I think especially the pandemic really kicked it into high gear. So the topics we're going to be talking about is how do you do rapid prototyping, go through continuous design iteration. In fact, I actually don't see a situation where iteration, design iterativity stops, especially if the components are going to come in and out of supply. We're having people having to go qualify substitutes and really rebuild their products on the fly, even as they're still building for production scale. So the waterfall model doesn't work anymore. You have to be able to go redesign your product as you're shipping it, right? Supply chains are really being restructured for resilience. We were seeing people put in more redundancy in place, bring it closer to North America, if not necessarily the United States, at least North America, so it doesn't have to traverse the ocean routes. Factory portability, that's really the holy grail, right? Being able to move your manufacturing process to any factory out there without having to go out there and meet people and kind of instill tribal knowledge on the factory floor. Digital technology lets us do that. And ultimately, software has to make all of this work, right? Ultimately, there's no reason why the cloud environment and a lot of, there's social media apps that are built, the Facebook outage notwithstanding, there's social media apps now built with a lot more resiliency than you see in a supply chain. they had an outage for 4 hours, but they're not having to cut 40% of their production because semiconductors are no longer available, right? So supply chain resiliency is a big topic, and we're going to touch on that. Right? So moving on, just a quick view into what kind of products we're talking about. The whole discussion today is going to be about electronics products, but we're not talking about PCB assemblies, and we're not talking about necessarily any particular type of assembly. We are talking about things that have PCBs in them, but ultimately get produced as packaged products that have enclosures. And as you all well know, products are not just PCBs, and products are not just mechanical parts. Products involve having to go source these materials, have them arrive on the dock at the right time for the factory to be able to assemble them. The assembly instructions have to be pitch perfect because a lot of times we have low cost manufacturing staff that has to assemble them. And assembly has to be high quality and repeatable 100% of the time. So there's a lot of testing, programming, packaging that happens in these factories. Not to mention what it takes to get the product to the customer for final delivery. In fact, we just saw an announcement a couple of months ago that Peloton is moving all of their manufacturing to United States, for example. It's not that they can't build the product; they literally can't get the product out of China, and the situation's only getting worse right now. Container ships are idling, out of the port of LA, and it costs 4 to 6 times more than it used to ship. So being able to do final assembly, right, and actually assemble the finished goods closer to your customers is becoming one of those important things. And for that, in that sense, it can't be a PCB or a plastics only problem. It has to be an end-to-end platform that can really deliver that and really deliver product to your customer's door. Right. One of the most common questions we get from people is when we talk about digital platforms, what kind of scale are we talking about? Because the service where you just upload a design and get some number of mechanical parts produced or some number of PCBs produced, fully assembled, turnkey, right? That's been around for a while, but we're seeing digital platforms go well beyond that. Obviously, the craziest example I gave you is being able to buy heavy machinery. But in an electronics world, we are seeing customers move sometimes their entire production environment onto a digital platform. Sometimes it's a portion of it, and that's one of the ways they introduce resiliency into the picture. They might be spending $15-20 million on manufacturing a year, and they'll move $5 million to a digital manufacturing platform. So we're seeing customers use this from volumes anywhere from low volume prototypes up to 10 units to low volume production. This is where we see a lot of EVT and DVT builds, and ultimately go to production to where we're producing thousands of units, hundreds of thousands of units. So this is an evolving use case for digital platforms. It does not displace the well-known names in the market out there. So if you work with Sanmina, Flex, Jabil, especially Foxconn, the electronics manufacturing market is over $500 billion. Foxconn is like 1/5 of that by themselves. So there's not a situation where Apple's going to use digital platforms to go build iPhones. They're going to be built by Winstron and Foxconn and Pegatron. But for industrial products, for anything that requires lower volumes, and lower volumes means less than 1 million units in a lot of cases, and especially high degree of iterativity, right? If you're changing your product a lot, digital platforms are becoming more and more compelling. So that's where we see most of the action happening these days. And that happens to be a lot of what we consume out there, right? So at this point, I want to hand it over to Ted because we wanted to take you through the entire production process all the way from the design stage to production. And that starts with design software.
Thanks, Misha, and hello to everyone. Good morning, good afternoon, wherever you happen to be in whatever time zone. As Misha suggested, these are complex problems, and part of the complexity is that moving to digital manufacturing isn't isolated to the manufacturing activity itself. It's really important that we kind of bring together what happens through sort of the life cycle of the product. And if you look at the way that our industry with electronics-based products works today, it's pretty fragmented. So, not just new entrants in terms of digital platforms and introducing digital concepts, but the way that we work historically is also extremely fragmented and maybe a slightly different perspective. And if you look at that, even in the design world itself, you've got many things. You've got requirements, you've got your schematic design, you've got physical design or layout, you have simulation in there. PCB is actually, rooted in art in many ways, and that's no exception today. Artwork and stenciling is a big part of creating a board. And then there's the bill of material. And of course, if you look at it through the pure manufacturing lens, it's equally complicated and equally fragmented. You've got many players there, and as Misha suggested, it affects or it's impacted by both what's available in the supply chain and the pricing in the supply chain, the brittleness of the supply chain, and the manufacturers themselves. So we have kind of like these as problems to deal with. And in many ways, I think a big part of what needs to be done is that we establish what I would call digital continuity, so that instead of very isolated activities where people communicate with each other, like Misha said, through phone calls and emails and meetings, that they can do that in a more digitally connected process. Michelle, if you don't mind, thank you. If I look at that through a slightly different domain, I guess I would say that I think of it in this way, that there are three very fundamental pillars for the creation of electronics-based products. And you can see electronics-based products today is almost everything that you could imagine. There's PCBs that exist in everything from your refrigerators and thermostats to cars to to televisions and iPhones and things like that. But it's literally everywhere. So it's a massive industry that we estimate at 2 trillion. A lot of that is in manufacturing, but from our perspective, these three pillars are literally disconnected from each other in ways that force us to throw things over the wall from one to the other. And one of the ideas or one of the concepts that this group has been talking about a lot is the idea of, instead of designing for, that we begin designing with. And that means bringing supply chain and the component manufacturers and distributors, the people who are designing boards and the people who will produce those boards, bringing them together on a single digital thread so that they can communicate with each other more effectively, more in real time, and more with the context that they need to understand what was meant, what was intended with the design, and why might I be able to make some changes, or why might I not be able to make others. But to do that in a really timely way, so that instead of having to go through many iterations up from design to manufacture, that we can kind of solve some of those problems while we're manufacturing. So we see it a little bit in that way. And if I just zoom in just to the, Altium is obviously a company who's, we make CAD tools for electronics fundamentally. And so, the design realm is the one that we are most familiar with and have the most expertise. And if I zoom in there, even that requires a very disconnected set of tools. So every time that we create a printed circuit board, somebody, usually a double E, is actually designing the circuit that's going to do that. He's responsible to make sure that we're creating an electronics-based product that works. And typically speaking, there are many tools that people can use, our own included, but there's plenty of others. It's a crowded space. In addition, those schematics almost always are simulated for performance. And you can see just from the list of things that are here, there's tons of those solutions too. Even schematic and circuit simulation aren't always connected together in ways that make it easy to move from one to the next. But now you link in layout, and that's actually looking at creating a physical product from that schematic design, how the circuit's going to fit onto a board. And then at the board level, there's simulation as well. And typically, you see this happen with high speed and high density boards where signal integrity is really important. But even in simpler boards, power integrity is an incredibly important thing to evaluate at the point when you are doing layout. And that's not something that you want to wait until after it's manufactured to find out something doesn't work in the way you expected. DFM, DFA, DFX, I guess you could say. Or sometimes I think of it as pre-cam tools to say, well, okay, the board functionally looks good, but now can somebody produce it, and what kind of problems are they going to run into? And then finally, we have to actually find everything that's going to go on that board. Now, as all of you would know, I think one of the challenges that we face in the electronics industry is that, unlike kind of mechanical systems, we don't produce every part bespoke. We don't go to a machine shop or to a vendor and say, produce a resistor for me, or a capacitor, or a chip. We have a supply chain and distribution network for the industry that we rely upon for that as well. And without digitally connected systems, how would you know what's available, what you should avoid designing into your board, and what you should look for in terms of alternatives you could rely upon, as an example. So all of these are fundamentally just disconnected things where I would say we throw things over the wall from one domain or one tool in the chain to another at best. And many times, it requires that we export things in some sort of intermediate file format and then import it into something else. And that is a huge waste of time in that a lot of the design context is lost. There's a lot of rework to be done. It just doesn't work really well. So Michelle, if you don't mind advancing to the next one, our view on this is that, and the reason why, why do we talk about cloud technology? Well, cloud technology is fundamentally the backplane for collaboration. That's the way that certainly that I see it and our team sees it. So we think that it's an incredibly important topic in this area of digital manufacturing and digital design and digital supply chain to connect these things together. And our attempt at that is to create a single information model or a data model that represents all things in a printed circuit board, and that's representing kind of like the base layer there. But then exposing that information model in the cloud or through cloud technology to, first of all, partners who can help to connect their solutions, partners and competitors for that matter, who can connect their solutions to that data model so that it can be presented to our customer community who work with design tools, but have them have a really seamless connection into electronic supply chain data or to software and technology tools like simulation tools, for example, or MCAD or PLM, and as well directly to the new breed of manufacturers, digital manufacturers who are coming on board, like Macrofab and like Xometry. And it's not critical for this talk, but the reason why you have two brands there is that we have the single cloud platform, one that's exposed to users through features and functions, and one that we call Nexar that is really a set of APIs and things like that allow partners to enter that ecosystem. But the whole point is that this is an attempt to unify that fragmented, siloed space that exists between design, supply chain, and manufacturing.
And Ted, if you don't mind, I wanted to jump in and add a little bit of color for why we think it's going to be important to do that. Two of the biggest problems that we see is, and they're actually very much related to each other. The design of the product really lives with the engineers, and it gets expressed in EDA tools or CAD environments. We find that the process of taking that design data and really imparting it onto the factory floor ends up looking like a facsimile of what it actually was intended to be over time. And there's a couple of reasons why that happens, right? For example, with Macrofab, we have native integration for Altium, but will be able to ingest data a lot better as we're starting to work closer together. But a lot of people end up having to kind of battle with their software, export things as ODB++ files, so you start to lose that native fidelity that is actually captured within Altium. Worse, if we have to ingest Gerbers, we are really just doing an interpretive dance that that helps us understand what the design looks like. So the closer we get to the design software itself, the better. This is the way that a lot of the cloud software got a lot more resilient. They stopped asking IT people to go set things up and they said, look, software engineers should specify how a cloud environment gets instantiated and how it gets stood up. So all of a sudden, the build environment became part of the package. And that data actually already exists with Altium data. We just don't always know how to consume it. So that integration is going to be essential. But there is an opposite reaction that happens, that once it lands on a factory floor, the design starts drifting immediately, right? And it happens through a series of well-meant decisions. I can guarantee it's happening right now with supply chain being where it is. There's probably a factory in China calling their customers saying, hey, all we got to do is just change the footprint of these components a little bit, and I think I can get you back into production. These parts are almost the same thing. Are you sure you have to go validate it? No, I'm going to be out of business if I actually go through the right process. So please make whatever changes, as long as it passes the functional test. Let's just get back into production. We've seen people that try to get out of the Chinese manufacturers and end up having a very different design than they thought they were producing. So imagine a situation where there's people on a design team that think they're building something, they're iterating. It's not exactly what's actually getting built in a factory. And this is where the closed loop of these platforms matters so much. In the model that we're envisioning, it doesn't get built on a factory floor if we don't specify it out of the Microfab platform for how it gets built. So factories shouldn't be changing the design, and the design changes are made. They should be, first of all, recorded in a place that stores all that data, but second, reflected back into the design package, which will be the way that things work over the next couple of years.
Yeah, and Misha and Greg, you'll remember that just an hour ago we were talking about some customer feedback where a customer of Altium's literally said, why is it that I have to actually take a design that I've completed and I feel good about, and I've run it through dozens or hundreds of design rule checks and DFM checks, and I have to export that into a format that loses some of the context, loses some of my design intent. I send it to a manufacturer who could be anywhere in the world, in a different time zone. He may speak a different language, and guess what? He's going to send something back to me in a sort of like an ill-formatted spreadsheet that then I have to interpret and figure out what did he mean, and then hopefully make those changes. And probably 2 or 3 days have gone by, and likely speaking, I'm going to go through that iterative loop 2 or 3 times for every board that I produce, right? So it's just really a waste of time and a waste of money and a waste of resource that we could streamline if we could connect these together. And this is Altium, along with its partners, attempt at or at least first attempt at solving that. So putting one cloud platform together that connects to the PCB design tools, that gives you the ability to do design review and design sharing and commenting and markup directly from a web browser without knowing design tools, that can plug in also the mechanical design elements, because we always have enclosures and other things that are part of a product system. And also to have a feed for supply chain data that's real time, directly from distributors, directly from manufacturers, so that we know what actually is available, and literally connecting to the folks in the manufacturing facilities, particularly Macrofab in our case, to be able to do this kind of like, again, that whole span from concept through to board in your hand and product in your hand, on a single digital platform. So that's kind of the way that we see the future, and what needs to happen in order to make our industry sort of work in a stronger way together, and literally meet the demand, the growing demand that we have for smart and connected products.
Yeah, so I'd like to turn things over to Greg. You obviously can't build electronics products without mechanical parts. And Xometry is one of the largest platforms of its kind out there. And I think the whole space went through a fairly fascinating journey. I think even as recently as 5 years ago, there were still people thinking we're going to be 3D printing this stuff at home. The factory is going to be at your house. That is not the way it's going to work, apparently. So Greg, would you mind taking us through what you guys do at Xometry?
Yeah, Absolutely, absolutely. And by the way, I will say there's definitely a use case for having your own in-house printer. And I think a vast majority of our customers do have in-house manufacturing. But what we have is also the capabilities and nearly unlimited capacity and global distribution and all that cool stuff. So there's always, like, I love people with printers because they know DFM for 3D printing, and it helps kind of save a step there. And also, Tadamisha, like, I feel like your comment about what happens sometimes when you overseas work, and then you think what you think's happening, what actually happens, that disconnect there. I think several times throughout my career, I've had kind of therapy sessions with customers over those experiences where they're like, I've had this this part made out in China or India, and the part looks good, but they want to onshore it, and they're like, this is the exact design that we make. Can you make it? And we come back with DFM feedback, and they're like, actually, just more or less this, because I want exactly what I have. And it turns out you find seek marks, other features on this, and we asked to get the original part that's been made overseas. And you can see every single mold tweak and design that was made, probably without asking the customer. And was it a bad decision to make those mold tweaks? No. But was it documented? No. And that was a big challenge there, is that digital thread didn't exist. It was tribal knowledge specific to that shop. And as you have disruptions like what we've seen with pandemic, weather events, you name it, that's happening right now and it's occurring more and more, that digital thread is so important for redundancy, because my inventory is not just my physical stuff, it's how I virtually communicate it, like how I digitally communicate it. And I think we're talking end to end, from my design, and my world is CAD, my world is 3D modeled CAD designs, to the production end. Having a platform to connect that is so important. But I'm jumping ahead here, but I just very relevant for that. And I really want to start off with, manufacturing is not a serial process, and a lot of times you're actually working on multiple projects at the same time. So this is a snapshot of what a project can look like. And I really like to bring this this type of timeline up, because it shows that things overlap. Production conversations overlap while you're iterating prototypes. And even with prototyping, I may be doing 3D printing, for example, or rapid machining, or urethane casting and create concept models. But we have enough information to at least start talking budget, start talking DFM, start talking how that design could be modified for your production viable processes. And what we see at Xometry is we're often going down those parallel pathways, working through, and just how important it is to bring that up in your conversation uh, early on, because it just helps you be more prepared versus a massive design change when you go from process to process, if you're moving, for example, to a hard tool injection mold process. But I just, I really like to show this timeline, because this timeline happens all the time. And again, that iteration is so good. But yeah, let's jump into what I see in my manufacturing world. If we want to go to the next slide here, very similar to what you see in PCB hardware development. It's a very fragmented system historically. You're usually doing that zip file with your CAD package, and sending out an RFQ, hoping to hear back. And what you hear back is not consistent. You don't see the average price of stuff. You see usually pricing varying all over the place, and the information is not always transparent. The communications, it's email, it's back and forth, and there's a lot of inbox diving, is what I like to call it, that you have to do. And when you are set with those suppliers, as we mentioned before, there's vulnerabilities there, and especially as we see more and more disruptions. First off, you're fixed with the suppliers that only you know about, where the window could be much wider with a digital marketplace. And there's capacity often that exists in the best suppliers out there that you may just not have that handshake, without certain digital platforms. And again, just that exposure to regional disruptions has just been very prominent right now. It used to be like a talking point, and now everybody's like, oh yeah, I'm having that problem right now, and this is where you find the real power of platforms. So let's go to the next one, just kind of an inverse. What happens, right, if I'm able to network together and create a marketplace for providers of manufactured goods of all different capacities and capabilities, different sweet spots, and I'm able to create a single platform, a single digital platform where you, as someone who needs something made, I need an enclosure for my PCB, you can go quote and get connected automatically just like as if you're hailing an Uber, or if you're looking for Airbnb and you're trying to get that out. There's not a dispatch there. It is just something that magically happens in the background. A lot of times we're doing AI and machine learning on our side to get that matchmaking to be optimized. But that's the power of these manufacturing marketplaces, and that's something that Xometry is. It builds a high amount of redundancy. It mitigates that disruption, and it really enhances those capabilities. We're not one shop that just is trying to tell you what our tool set is and design and make parts in that tool set. We are actually expressing and kind of celebrating the differences that shops can have, and also celebrating that some of these shops have sweet spots, and we're pricing to those that kind of like local shop feel by doing intelligent matchmaking using AI. And for if you are a larger company, if you are used to more contract manufacturing or working your supply chain, you may notice that you've aggregated thousands of suppliers along the way. Moving digital platforms like Macrofab, like Xometry, it does actually consolidate that. It's like at one click, I get 5,000 shops, and it's just very very exciting that way. But yeah, we can run to the next slide here. This one's going to be really quick, but the summary of this is it's e-commerce experience. I'm taking a design that may have never been produced in the history of the universe, and I'm now able to not think about who am I shooting this work out to, and just upload the file, get a price, and press buy, and have guarantees against the quality of that product. And it's a very, very different experience, and it's a very more auditable experience because everything is tracked from your file CAD to the provider, to the status updates of the provider, to the shipping information, to quality documentation, not just tied for the product itself, but tied for that instance, that lot run that the product was run in. And that's all universally chained together by using a digital platform experience. And I do want to highlight this. We're not talking specifically about DFM and other technologies today, but by being able to celebrate diversity in manufacturing, you have a one-stop shop feel. So for example, I work in 8 different additive manufacturing technologies, 6 of which are plastics, 2 of which are metals. We also do subtractive, everything from small Swiss term parts to standard parts, 3, 4, 5 axis, gantry parts, sheet metal components, you name it. And again, these things could just be up. Your BOM for mechanical custom goods can be uploaded, and each one will be respectively sourced with the click of a button. And of course, when we talk about PCB, PCBAs, a lot of times they're living in that realm where you may have a molded enclosure or some sort of molded component, and whether that is a domestically sourced aluminum short run production tool, or it's an internationally sourced economy tool with some automated slides, or if it's a full scale multi-cavity production tool milled out of stainless steel with all the works. Like you can go to one single place for that type of work, and it's often very refreshing, because 8 years ago I was in the position where I was sourcing and having the same headache. So actually we've gone a very long way in the last decade here. Let's go to the next one. And again, I spoke mostly about this, but one of the powers to a digital platform is you do get to get information, right? So we're able to train and find what is market fair. So again, without you searching around and trying to find a fair price, we're actually using AI, and we're paying our suppliers because we're working both the buyer and supplying side of the world. So we actually know what something costs. And so you could actually use AI machine learning as a platform to get more than just the sum of the components. You're actually able to give a much more accurate pricing, much more dynamic and accurate lead times, and ultimately that also gives us information for, say, like your part. If it's machined out of Delrin and has these features to it, we have these plastic providers that we think are like 98, 99% matches for that type of product, and we're trying to make that match happen. So there's a lot of power when you work with digital platforms. And for you though, it may just be click and buy, very, very simplified. We do the work, we do the lifting on our side.
Thank you, Greg. Michelle, if you advance to the next slide. This is an interesting view of of the product ideation process, and there's a link there to the source. Bolt has a lot of great guides on how the design process goes. What we really are interested in most is the process of getting from the engineering prototype to a product that can really be put into customers' hands. That's going from engineering validation to design validation. That you don't build 100 units of something for the engineers to play with. You do that to put into customers' hands. Ultimately, you're going to go to a production validation run, which actually assures that your factory that you've chosen for production is ready for production. And as I mentioned earlier, we don't see a lot of our customers necessarily using those terms. Sometimes they try to skip stages, but rest assured, you always go through this process. Even if you're rushing into production, you almost always have to go back and redesign your product. And in fact, people are starting to come to terms with the fact that you're really never done. You're always going through another rev of engineering prototypes. You're always moving to another set of design validation stages. But suffice it to say, this is all a waterfall process. It is meant to be done in sequence. And a lot of times you're not actually even doing this with the same factory, and for a very simple reason, right? If you're trying to scale up to let's say 500,000 units a year in volume, that factory is really a perfect weapon for building that kind of volume. And they're uniquely awful at building 100-unit prototype runs. They're doing it for you as a customer because they want to get the rest of your business. But really, customers, I think people realize that for that reason, they end up working with 2 to 3 factories in the stages. So what you end up with is a waterfall, throw it over the wall process where one factory builds up to maybe 100 units, another factory takes over at that point. Then they hope to land in the right place that's going to be able to build the product in volume. But even that might not always work out. You'd be surprised how often either customers fire their factories or vice versa. The factories, in fact, fire their customers. And that happens when, like, look, you've burned up so much of my time with your prototypes, I'm just done. We see factories doing things like that. They're saying 2 years of prototypes, you haven't produced anything close to $500,000 units in volume. So customers end up getting disrupted because they're not in the right factory. That factory and customer matching is actually very important. And in the traditional process, it really doesn't work right. There's a lot of pain and frustration that comes with it. Michelle, if you go to the next slide, it's very different the way we engage with our customers versus traditional manufacturers. Because we're a digital platform, engineers can actually order whatever they need through an interface very similar to that of Xometry, but for electronics. In fact, they can take an Altium file, upload it to our platform, upload their bill of materials. We actually have integration with other parts of Altium already. We're an Octopart consumer, so we give customers real-time view into how much supply there is, what kind of materials are available. They can choose substitute parts immediately in the platform before they even go to production. So all of it, and it starts to build out their digital package for what's eventually going to end up on a factory floor. But if they're going to go to production, we have a set of teams that actually take it to production, take it through the NPI process. So these customers go through the NPI with Macrofab, and ultimately we land them in whatever factory makes the most sense for them. So it's a much better process. Michelle, go to the next. We'll go to the next stage. Because we're using a digital process to govern everything from prototypes to production, what we end up doing is using a single platform for every stage of production. Customers can now do continuous EVT, DVT, and PVT cycles. We have customers changing products all the time. It doesn't necessarily disrupt their production cadence because they don't have to go to multiple factories and then retrain them. Greg mentioned the term tribal knowledge. That doesn't have to happen in this process because we are essentially choosing the right factory for every stage of design, even if we end up at some point in very high volume factories, in multiple factories in parallel, so that factory portability, right, and ability to have an elastic factory, right, because Greg and Xometry have something like 5,000, I believe, machine shops, 3D printing shops. Some of them are larger, molding environments. Electronics world is a bit smaller than that, but higher volume. So we have about 75 factories that are in our network right now, but that lets us build products at very high volume, start out at very small levels in US and Canada, but move it to Mexico when the time comes to get advantage of low cost manufacturing, right?
Yeah. Amisha, I was gonna, yeah, I was gonna add to that too. This digital marketplaces have also opened up a new way of thinking about production. And I know we were chatting about this a little bit earlier as well, which is how I think about lot sizes. You know, and also I think Ted mentioned how I think about revisions. Because whenever you do move to production manufacturing, you're building a line or building a tool, you know, all of a sudden it's very rev sensitive. And with these digital marketplaces, because you're kind of doing the matching for them, we tend to see more iterations where production part is less rev sensitive, or it's less of an impact for our customer on their wallet, essentially, if they do have a rev change or an update, or they want to move to the next model. And are you seeing that in the electronics world? Yeah.
We're seeing it both in electronics, but also with mechanical parts. I distinctly remember a customer that was they were going from about 100 units, but scaling up to 10,000 units. And their dilemma was they didn't want to order their final molds because they were still going through iterations for their clamshell design for their enclosures. So their trade-off was actually pretty simple. It may be more expensive per unit to keep 3D printing these enclosures, but they actually went to several thousand units in production before they actually cut their molds, because they had a feeling they were going to keep iterating, because they just weren't happy with the fit and finish. They were, they were still tweaking the design. So the impossible, the question was, how long do you want to defer production? The answer was, we're not going to defer it at all. We're going to keep 3D printing, cover 1,000 units at a time of these shells. And it was up to us as the final assembler to make sure that we can manage that entire process, including at some point switching over to a fully molded design and start to produce in higher volumes. We see the exact same thing with electronics as well. In fact, it's not possible for factories that are really good at high iterative electronics production to also be really good at mass volume production. So we have, our platform moves customers from one factory to another. And look, it does require sometimes our team getting in a plane and going down there, but it's not done by the customer. And in fact, that's one of the ways that it's been very pandemic proof, is that we already have a team in Mexico, for example, so we don't have to reinvent the wheel or charter jets in all cases, right? We actually have people on the ground that can go to that factory and get something done.
Yeah, that's like our Asian team, the exact same benefit for sure.
Yeah. And you can see, you can imagine that scaling out to a very, very large scale. I mean, I used to work in data centers, and I haven't been to a data center in about 10 years, right? There are things you do in data centers. You go reboot stuff, you go plug in new servers. You don't do that anymore, right? There are hyperscale infrastructure providers that do that for you, and I think we're going to see that level of abstraction coming to this space as well. So that's essentially how our platform works, right? Customers upload their designs online. We have a single platform that keeps all of the relevant information about manufacturing in one place, even as it's changing on the factory floor. Microfab sources all the materials, including mechanical parts. In some cases, they come from Xometry. We then choose the factories and drop those production kits onto the factory floor where they get produced, and they come back. The product comes back to us for final testing. In some cases, packaging happens at Macrofab. In some cases, that happens on a factory floor itself. But for a lot of our customers, we'll actually be the warehouse and a fulfillment arm. You can actually upload a list of customers to us, and we'll drop ship product directly to customers in a lot of cases. So we really are abstracting customers from the need to go be on a factory floor. So it's really the vision of software-enabled manufacturing. There's a single source of truth for all your manufacturing data. I think one of the coolest things we can do is PCB versioning and change tracking, and that's different because you obviously have versions and revisions in Altium, but these are PCB versions and changes that are actually with a BOM attached to it, and changes that are done to specifics of what the manufacturing process entails. And we have customers literally going back and rewinding and figuring out what change did we actually make that went to the factory that caused this particular issue, right? It's all API accessible, but most important, I think, is that it really pulls in all of your inventory into the picture, because it's impossible to build these products without managing inventory. So we source inventory. We have customers consign inventory to us. Part of what we do is not just software. There's a giant warehouse where we stage the materials and then assemble them into kits, deliver them to the factory floor. And for a lot of our production customers, we'll actually develop, sometimes they'll have test fixtures for us to use, but a lot of times our design teams will actually design the test fixtures, and they come to the factory floor as part of the production package, right? So, for earlier stages, right, it's the engineer that's doing functional testing on their bench. Later, right, this happens on a factory floor, and it happens according to instructions that our platform generates for those factories. So we wanted to take a couple of just very open topics and just discuss. Then Michelle, would you mind going to the next slide? I'm happy to take any of the questions you guys have, but the most common questions we get on this topic are, does this really help with accelerating around supply chain disruption? And I think the other question we get is, what does it look like 3 to 5 years from now? And probably the most ubiquitous question is, what is exactly Industry 4.0? Is it anything more than a bunch of white papers and graphics, right? So let's start with with supply chain disruption. And Greg, I suspect our story is pretty similar in some ways, because we have a network of factories out there, so we're not necessarily beholden to any region, right?
Yeah, and I think one of the strongest ways I always describe, marketplace manufacturing is that it utilizes capacity and talent that's there. That spindles that aren't turning that could be turning first is one of the most powerful things, because often these providers who are perfectly capable of hitting timeliness, quality, and the specs of your project, they are out there, but that the visibility, the handshake just isn't there. And that's something that digital platforms you truly excel at. And when we see that, and again, this going back to the whole geographic dispersion and everything else, but it's true. I keep on saying it because it's very true. When you're able to actually utilize capacity that already exists, it does a couple of things, right? It helps you get your project done, but it also, keeps work going to, in our case, like we work with small business manufacturers, especially on the CNC machining side, because that is most of the talent of CNC machining is the machinists themselves. Same with sheet metal fabrication, and so like you're able to keep them power, keep them getting work through. And I've found that as like, especially when you start seeing those disruptions, how powerful that could be to basically just be able to do a shift. Or for, we had some medical product lines that we needed to get out quickly, and we even we triple sourced, right? We're able to actually build multiple sources to accelerate, because no one provider could have hit the speed that was required for that product line. And so like that's a very, very powerful tool there.
Yeah, and I know raw material sourcing has been one of the because the headlines are all about semiconductors, but that's not actually what's slowing us down most. It's raw materials. Things are sort of back on track at this point, but copper was in short supply for a while. There are days when we can't find epoxy. Some of the most pedestrian things are just in very narrow supply. So I know that's part of the platform benefits that Xometry offers, not to their customers, actually to their suppliers. Actually, they'll sell because they can source in a very, very different volume, but they'll actually provide materials for some of their suppliers. We do the same thing, but we're actually in even a tighter posture, because we can't build final products if we can't source the materials. So a lot of what we've been working with our customers on is sourcing alternative parts and be able to go find, and our engineering team will actually work with customers and figure out, here are the substitutes you need. But here's the thing about substitutes: there's a lot of times actually either a different package you can choose that's functionally the same, but really needs to be, it's it's the packaging itself that's different. Sometimes it's literally just a different product line, of some component that's designed for hi-fi audio, but it could also potentially be used in industrial applications. Now, what you want to do is be able to turn a fast, prototype, put it in a lab with the customer, and be able to have them validate that the substitutes they're using are in fact relevant. So beyond our ability to go find parts where somebody else might not be able to, and we do that, the biggest weapon is actually the iterativity and ability to take that new design and put it into production, right? Which is difficult to do when your suppliers halfway around the world, but especially difficult to do when they're not digital, right? If you're sending email manifests of what gets, what needs to get built, first of all, you're gonna end up with a lot of excess inventory that you don't need, right? Second, there's gonna be stuff lost in translation. So ability to iterate faster has been probably the biggest difference maker. I would say the third one is all about time compression in places where it matters. And to give you an example, right, again, because we assemble finished goods, the last part date is the most important project aspect that we manage to. And at the end of the day, especially if semiconductor parts are not available, we have to wait for them like anybody else, right? But here's the thing, right? There's a big difference between your supplier in China waiting for semiconductor parts, assembling the product, and then starting the process of waiting for the container ship, and then starting the process of transit, which could take 4 to 5 weeks to get from China to US, then idle by the port of Los Angeles for a couple of weeks before the container can get offloaded. That is actually within your control. So our advice to customers has been, you don't need to move all your production out of China, but you should have factories set up in Mexico to where we can get the raw materials into Mexico, assemble them in Mexico, and at that point we have a lot of ways to get out of Mexico, right? We're using land routes, and even when they shut down the border for whatever reason, the commercial trucking still keeps moving, right? Even in the middle of the pandemic, we really didn't see disruption in transit. So big impact, and again, ability to move quickly and be able to source a different factory in a different country, especially one that's closer to your customers, is essential for doing that.
All right. Great discussion, guys. Thanks so much, all the panelists, Misha, Ted, Greg. Great conversation, great presentation. I see all the attendees hung around for the entire presentation. I don't see any questions from you. Feel free to send your questions.
In that case, then I think we got to address the Industry 4.0 question. Look, here's the way I think about it, right? Somebody's going to write a book about what's happening to the manufacturing industry today, and I think they're going to call this era, the Industry 4.0 era. But other than that, it's not a thing, right? What Ted is working on at Altium, what Greg is working on at Xometry, what we're building at Macrofab, and how these companies work together. How do we actually help somebody build real product through software-enabled technology? That's real. At some point in aggregate, that's going to be called the Industry 4.0 era. But it's not a product, it's not a service, it's definitely not software. So it's coming. And by the way, I think it's happening much faster than you might imagine. There's a lot of people moving faster now because they're using those digital platforms. But Industry 4.0, I wouldn't wait for the switch to go off. It's not going to happen that way.
Yeah, great stuff.
What I would just add to that is that I look at Industry 4.0. It's a buzzword, a little bit like digital transformation. And if you look for the sort of like holy grail or some magic bullet that says this is what it is, I think we're missing the point, because it is taking place around us right now. And the fact is, what we've seen is that it was accelerated by the pandemic, because people found themselves having to work from different places, and this is the only way they could work. And I think everyone who's tried it has found that they're not going back. And so I think, Industry 4.0, digital transformation, those things are upon us. And like you said, one day people will write about the things that are happening now and say, that was it, that was the genesis of it.
And I think just like the cloud enabled a lot of smaller companies to move faster. I mean, there are multi-billion-dollar companies now that just didn't exist 10 years ago. It used to take decades to build a multi-billion-dollar business. That's going to start happening here. Like we just saw Tim Cook appeal to Congress and say, look, China doesn't have enough coal to run some of their factories, so that's going to impact what we do at Apple. I can't help Apple at their production scale, but that means that somebody out there that's competing with Apple now has an opening, right? And that's where real innovation really starts to happen, right? We're going to see companies come to market faster, and because they're able to be more agile, they're not going to have the economy of scale and the immense supply chain that Apple and Dell have, but they'll have the ability to move faster, and that's starting to become a game changer in electronics.
And I'm seeing that, on my mechanical analogy here, but you see a whole division of new space, privatized aerospace, definitely, moving at rocket speed, pun definitely intended there. And one of the things they take advantage of is, digital platforms, is all these tools that are available, additive manufacturing, these technologies that sometimes become very prohibitive in larger companies to adopt because of other standards and just adoption policies and bureaucracy. So yeah, you see a lot of hyper competitiveness happening, but also like just that adoption of digital tools and platforms like what we offer. It's very exciting to see.
Guys, thanks a lot for your time. We're starting to lose people, attendees, because they're switching over to their Zooms and probably going to work. But great discussion, and we will have this webinar published. So if your friends weren't able to join us, we'll have this available for them offline. And we're looking forward to more discussions like this. There'll be an entire series that we're doing with Altium all through the end of the year. So stay tuned.
Thanks so much.
Thank you.